what GTAW stands for?
Gas, tungsten, arc welding.
And man, you agree. All right. So gas, tungsten, arc welding, that's what this setup is here. So we've been doing a lot of stick so far this year, right? Some of the advanced students have been doing a little bit of GTAW welding or TIG welding, they also call it. So here's just one example we'll pass around so people can check out what TIG welding looks like. And then this is also an electrode. This is what transfers the arc to your piece of metal. Notice how it's ground on the tip compared to, say, this one here. So when you're setting up your equipment, you've got to get your tungsten tip ground to the right shape for it to work the best. So why doesn't everybody take a piece of paper here, take notes. We're going to have probably a quiz tomorrow on just a few of the things that are listed on the board there that are our learning targets. So everybody understands that TIG welding and GTAW welding are the same thing, right? Does anybody know what TIG stands for? It's not written on the board. So GTAW was easy because we wrote it out, but what does TIG stand for? Yep, that's it. So tungsten inert gas, that's right. So you might want to write that one down. That's a possible question later on, tungsten inert gas, and then also GTAW, because they're interchangeable terms in the industry, so you want to know both of those. And then we'll take a look at a couple of the electrodes. So tungsten is what transfers the arc to the metal, and there's different types of tungsten. So we've got three basic types that we use in here and that industry uses also. There is more, but you'll get more into specialty types. So you've got thoriated, which is probably the most common. Can someone write thoriated on the board for us so everybody can see how that's spelled? Sure. Thank you. Thoriated, yep, so it should be right on the box there. So thoriated is a good one to use for both AC and DC TIG welding. So does anyone know when we'd use AC versus DC, or most commonly, or what the difference even is?
DC is for steel and other metals. AC is for aluminum.
Right. So those are the most common uses. We'll each stand here and write the other two. So I'll do this one first. Actually, we'll do one over there. So you'll use DC most of the time unless you're doing aluminum. Aluminum and a few other alloys are the only ones that you're going to use AC on. But if you don't switch it to AC, you'll have a tough time welding aluminum without it. So AC, alternating current, DC, direct current, right? Most of your welders now will have an option. This one's right here. You can just push the button to switch between AC and DC. And then the next one that Shayleon wrote down there is seriated tungsten. So seriated is pretty good too. It's not quite as durable as the thoriated. And it's used mostly for DC. You don't use the seriated on AC welding as much. And then the last one she's writing down is lanthanated. So lanthanated tungsten. Again, it would be used mostly for DC. Okay, thank you. So we'll pass these boxes around now so you guys can check them out. And tell me, as it goes around, tell me a couple different things you notice about the rods in those boxes. You could open them up too. Pass some rods around too. What do you notice that is different about the tungsten in those boxes?
We have different color coordinates.
Okay, different color on the ends. There's one thing. Anybody have an idea what that would be for?
Make sure you don't get it mixed up if they're out of their boxes.
Right, identification, right? So when you sharpen your tungsten, you want to sharpen it on the opposite end that's colored. So you keep that colored end on there as long as you can so you know what you're using, or you can check it real easy. What else do you see different in there? Anything? Where'd that one that I started off with end up at? So check that. Check this one out compared to this one. What do you see different about those guys?
Bigger.
Bigger. So diameter, right? So what would we have different? I mean, why would they make different diameter tungsten? Somebody new, take a guess at it.
Bigger metal.
Bigger metal, so thicker metal. So if you're welding thicker metal, you'd probably be using a bigger diameter tungsten, right?
Does it make a bigger arc?
Yeah. So it can handle more amperage, right? It can handle a hotter arc. The thicker the tungsten you go, the hotter the arc you can burn, the thicker the metal you can weld. So we've got some that get real tiny, like when you see those guys on YouTube or whatever welding pop cans and razor blades, they're not using a tungsten like this that's 1/8 inch or 3/16. They're using a little tiny tungsten where they have it sharpened to a real fine point. That's a good one too. So when we sharpen our tungsten, which way do we sharpen it on the grinding wheel? Do we sharpen it horizontal like this and grind around it? No, we want to sharpen it in line, like Justin's saying there, so that your grooves are running parallel to the rod itself. That'll help you have a more stable arc while you're welding. And then, if you're welding something really thin, you'll go ahead and take it all the way to a sharp point, the needle point. But if you're going to weld something that, was probably, say, thicker than 1/16 of an inch, you will leave just a little tiny flat on there, or you'll take it to a point, and then you'll put just a little bit of a flat on there, real small, and that'll help stabilize it, it'll help the arc start easier, and it'll make your tip more durable so that it doesn't want to blow off right at the start when you first strike it on. Yeah.
How often do you have to sharpen it?
So yeah, that's a good question. Anytime you touch your tungsten with your rod, your filler rod, or you touch it to your plate, you're going to want to sharpen it. Now, when you're welding aluminum, you don't take your tip to a sharp point. Aluminum's different. You'll leave it as a ball, and it'll actually ball up itself. So when it's a ball, you can actually get away with running and keep running a little bit. It'll still be contaminated. So if you're welding something to code, you would still need to stop and grind that ball off and start over again. But if you're just welding a home project, you can actually touch it, keep welding a little. Whereas if you have a sharp tungsten and you touch it, you're going to want to resharpen it right away. So different sizes, different types of tungsten. Everybody's got the 3 different kinds here. Then also filler material too. So let's start these over here. We'll just pass these around and somebody name off what kind of rod they see there. What kind of material do you think it is? Throw out some guesses. Aluminum. So aluminum is one of them.
Copper.
Not copper. It does have a thin copper plating on it. That's to keep the steel from rusting. So the ones that look like copper are usually just mild steel, but they do have thin copper plating. Because unlike stick welding, when you're TIG welding, it needs to be a lot cleaner, right? TIG welding doesn't like to weld through dirty material, so they put that thin copper coating on there just to keep the rod from rusting even a little bit. Same with your aluminum rods. A lot of times they'll keep them in a sealed box. So when you use them, they are not oxidized. If you keep them out in the open air, like some of ours are, they'll be more oxidized. They'll have a little bit harder time welding with them. It'll be dirty, real dirty puddle. So what else do we got beside mild steel? Someone else write on the board for me. Mild steel. Anybody? All right. Nobody knows how to write with Haley on it in here? Okay, so filler rod types, or fill rod material, let's say. So this would be a good one to note too, fill rod material. And we said aluminum and mild steel so far. There should be at least, okay, stainless, good. Aluminum. And stainless. And mild steel. Okay, so what would be the reason for so many different types of filler rod? Yeah, different applications, right? So you want your filler rod most of the time to match whatever you're welding, right? So when you're welding aluminum, you definitely need to be using aluminum filler rod. Whenever you're welding stainless, you want to be welding using stainless filler rod. You can weld, TIG weld cast steel, cast iron, and a lot of times you would use stainless on that. So there's another one in there. It's kind of hard to tell, but somebody might guess it. Yeah. What's that guy right there? That's bronze, yeah. Let's put bronze down. Yeah, and they have a little bit of silicon in it to help it flow better. So there's four types of filler rod. There is more, but then, I mean, those are kind of the basic ones. They kind of get more exotic if you go outside of those. Okay, so there's our filler rods. And then we said earlier, TIG stands for tungsten inert gas. So that leads us to what are the two common types of gas used when you're welding TIG? There's one basic one that's almost universal. Argon. So straight argon is by far and away the most common gas. And why do we call it inert? Why is argon an inert gas? Has anyone heard of that term before? Inert chemistry or something? So inert means it's not going to have any reaction, any chemical reaction with other types of gas or material.
So it can't like blow up or explode, it's kind of like a safe gas.
Right. So they call it a shielding gas, and yeah, it is safe. So its job is to keep the weld really clean. I mean, remember earlier we said you wanted a clean environment for it to weld, and its job is to cover the weld the whole time you're welding, keeping it clean. It provides a cleaning action. And then the next one, not quite as common, but still used, is helium. So they use helium or a mixture of argon and helium when you want to get a higher heat level. Say you're welding something really thick and you don't want to use multiple passes or as few passes as you can. You'll mix helium in there and allow the weld to cool temperature to go up. Okay, so you've got filler rod, you've got the gases, you've got the tungsten. So now let's take a look at each one of these parts of the welder itself. So this is what they call the torch body. This is what you're actually going to be handling when you're welding. You've got the torch body, and then you'll be running filler rod in your other hand usually. So the torch body holds different parts. And this is called what? Anyone? Cup. So just like they have different sizes of tungsten, different sizes of filler rod, you've got different sizes of cup. When you're welding small stuff, we'll pass these around, everybody can check them out. When you're welding small stuff, naturally you use a smaller cup. And then we've also got collet bodies. So these are the collet bodies. These are what actually grips the tungsten. When you're loading your tungsten in your machine, you'll slide it into the collet body, and then using the end cap, different kinds of end caps too, right, for different lengths of tungsten to get into smaller or larger spaces, depending on what your job is. You use the end cap to tighten down the collet on the tungsten. And so this part here works in conjunction with the column body to hold your tungsten, but this is called a gas lens. This helps diffuse the gas as it comes out of your welder, because you've got gas and electricity flowing here. This is your gas. As the gas comes out, the more even pattern of shielding you can provide, the better your weld will be. Then you've also got an insulator here. This is to try to keep the heat off the torch body as much as possible. It goes between your gas lens and the torch body itself. And then the end cap, this one little stubby one, you're going to be using a tiny short tungsten to get into small spaces, right? And then they have longer ones too. We had a medium one here, but they have long ones about like this that'll hold the whole tungsten rod, so you don't have to break it in half to start with, if you have more room to work with. Okay, does anybody have any questions this far on anything? Nothing? Alright, so this is your regulator, right? When you're welding, typically we want to run about 20-25 cubic feet of gas an hour, argon in this case. So you'll turn this all the way on, and then you can step on the pedal to get the gas flowing, and you use this knob to adjust your regulator here. It's got a scale right there on the side. You'll adjust it until there's a little ball that floats up to get that 20 to 25 cubic feet of gas flowing out. So now I guess, who still hasn't completed their box project? Okay, so about half, well, quite a few of us in this class. So go out there, start working on that. Let's try to get that finished up and tested today, if possible. If you are done, then let's go ahead and start doing some practice welding on the TIG. If you're an advanced student, go ahead and add filler rod. We'll work on just little stringer beads. If you're new, try just running some puddles, making some puddles with the TIG as we go with no filler rod to start with. And then I'll help demonstrate that when we get out there. You got a question?
I was just saying when you were last talking about a weld to do, would that work on the boxes that we got holes in? You could just put that over the holes?
Yeah, you'll want to add filler rod doing that, because if you just keep trying to go back over the same weld without it, you'll create more holes a lot of times. But yep, you could use that, plug holes. Yep.
Okay, so once we're done making our box, what do we do?
So once you're done making your box, then we're going to drill a hole in the top of it and tap it, and we'll put in a little air fitting so that we can pressure test it underwater. And then that'll show us if you have any leaks at all in any of your welds. So I'll help show you guys that out there too. I think both my other classes are done. One's a lot smaller, so it's easier, but even the third period's done. Pressure testing most of them, so let's get out there and get started.
What's really doing this?
Yeah, take this back out.
What do you just need?
Gotta have a few written assignments. No, just, yeah, stop it and just take the whole thing out there.